right, so we'll kick things off and get started. So today we're going to talk about how to use unstructured with MCP. I am your host, Nina Lopatina. I'm a staff developer relations engineer at Unstructured. I've been here for almost a month. It'll be a month, almost a year. It'll be a year later this month. And prior to joining Unstructured, I worked in natural language processing and language modeling across startups and venture capital. And I'm joined today by Ajay and Tarun.
Hi, I'm Ajay. I work as a developer relations engineer at Unstructured. Prior to this, I've been with Unstructured for the last 3 months, and before this, I was working as a machine learning engineer, building like retail and document processing pipelines.
Hey guys, my name is Tarun. I'm also a DevRel engineer here at Unstructured. I've been here for about 6 months now. And previously, I did ML research at NASA, working on climate science, and also built document processing pipelines as a machine learning engineer.
Great. I'm excited to have you guys join and share what you've been building around MCPs and Unstructured. So for our agenda today, we'll do a quick intro to Unstructured and our thesis, and then we'll do an intro to Model Context Protocol overall before going into the specifics of what we've built for our server and a specific integration with Firecrawl to use for RAG. And then we'll demo all of these things, including our unstructured platform, just to show what we're accessing via MCP. And then over the past week or so, we hosted an MCP hackathon where we encouraged folks to hack with the unstructured MCP and gave out prizes. And so we'll showcase those 3 winning projects. A little bit of housekeeping before we get started. If you want to share something in the chat, like where you're joining from, you can use the chat button. If you have a specific question that you'd like us to answer, then please put that in the Q&A box. And so we'll answer that during the Q&A session. And then we also have some pre-submitted questions, but sometimes we start with the live ones. So if you submitted a question before, if you submit it in the Q&A chat, we'll definitely get to it. And we'll send the recordings to your email after we wrap up, in addition to the slides. And if you're interested in setting up a guided proof of concept with us, you can schedule a one-on-one chat to learn more after the session. And so Unstructured is a Series B startup. We started about 2.5 years ago at the dawn of Gen AI being popular. And our focus has been solving this rat's nest problem. The rat's nest being what you end up with if you try to build ETL for Gen AI yourself. You can have 10 different packages for different file transformation, for different file types or components within a file. And this transformation piece was really what we focused on for our open source and the version 1 of our API. And that rat's nest really expands as you try to cover the full end-to-end pipeline between where your data, unstructured data lives and where you want to store it as you add more and more components to do embeddings, chunking, and other steps in that process. And so unstructured really just fits very neatly between the systems of record and graph and vector databases so that your unstructured data is available to your LLM or other Gen AI application. And so we do this really seamlessly where you don't need to construct any of that rat's nest yourself. The way that Unstructured operates is a kind of an assembly line of different integrations. So once we extract your data, you can, for example, use Gemini to partition your data. You can call Anthropic to set up contextual chunking for your chunks. You can enrich by adding an OpenAI module for image summarization or named entity recognition. And then you can choose a model from Together AI for embedding. And then we load all of that to your vector database or destination of choice. And so this lets you avoid the API key scavenger hunt, since you don't need to set any of these up. You don't need to optimize any of these components, and you can really seamlessly switch in and out different providers based on, who's released the best model in the past week, or characteristics of your data. And so MCP has really become really popular. It was, I think it was picked up by Anthropic in November or so, and the last month or two, it's gained broader popularity with OpenAI setting up an MCP server as well last week. And MCP is Model Context Protocol. And so that's an open protocol to standardize how applications can provide context to LLMs. So it's kind of like a USB-C port for all your various AI applications. It just lets them plug in more seamlessly to your LLM. And so some things you can use it for would be standardizing context delivery to LLMs. You can use them to help build complex workflows and agents by setting up new tools for them to use. This makes them more reusable and interoperable. And then this can simplify the integration with different APIs, and we'll focus specifically on how this simplifies the integration with the unstructured API. So some examples of commands that you can now use within your LLM. You can say, transform these PDFs into JSON, convert data from this S3 bucket to JSON. You can specify a really specific workflow with the different steps of transform, chunk, embedding your data in Google Drive with a specific model, pushing it to Pinecone. And this would work with any of the features that we have available in Unstructured. And in general, MCP servers can provide three main types of capabilities. So resources or file-like data that can be read by those clients. You can set up prompts like pre-written templates that help users accomplish specific tasks. So let's say you have like a marketing workflow and there's multiple steps and you have a specific topic that you want to focus on. You can have these pre-written templates that would help you complete the full pipeline. And then tools, which are functions that can be called by the LLM. And so the way that we've set up the unstructured MCP is going to be a tool that the LLM can leverage for ETL and file processing. And tool use has become really popular as LLM limitations have been demonstrated. For example, some early tools have been using the internet for getting more up-to-date information, calculators, because LLMs are not good at math, and other APIs that they may want to leverage to have kind of a complete ecosystem that the LLM can interact with to be a full agent in the world. You can think about, a travel agent LLM that can access APIs to book cars and flights and things like that. And so we'll focus on this kind of tool setup. There have been other ways to provide context to LLMs. Retrieval augmented generation is a way to provide, to allow LLMs to retrieve context from a knowledge base. And then agents have previously been able to access these more general tools like calculators, knowledge bases, and websites. And now MCP allows for more tools to be created more easily for these agents to use. And so, so the MCP allows you to build these tools for LLM agents that you don't develop. And so your host with your MCP client, for example, Claude, as we'll be demonstrating with today, would have access to multiple servers via the MCP protocol, and then those can connect to different local data sources, or you could have one that connects with a web API to the internet, as an example. And now I'll turn it over to Tarun to fill us in on what he's built for the unstructured MCP.
Thanks for that, Nina. So Nina just described what MCP is and what the unstructured API does. And MCP, as it is a way to standardize, tool usage and how LLMs can interact with all the APIs that we have out there. And the unstructured API is an enterprise-grade option for you to process your documents, set up workflows, manage your connectors, and do all of that. So the fast MCP server that we came up with, the unstructured MCP server, is an official implementation that we came up with to combine the both of these in such a way that now you can now call all of the functions within the unstructured API through an LLM just using natural language. And this in the previous slide, you noticed how MCP works based on a client server sort of architecture, right? So we came up with our own server implementation that you can use to, we'll be showing you a cool demo later on how to use this, but you can just use natural language to prompt and access different components of the unstructured API directly without having to like write the code, run the code, and do all of those things. So since it's a server implementation, I'm just going to give you a quick sneak peek into what the code looks like internally. And this that you're looking this code snippet that you're looking at over here is like the most base instance of what the server looks like. We want to have the fast MCP server that we've written, and along with any context manager that you might want to use. Within the context manager, you want to hold, like, for an ELI5 way to look at this is essentially this contains all of your client related objects that you want to run on for as long as the server is going to be running without like kind of deleting as an object or anything. So we establish our API keys in here. And then if you notice, we instantiate our unstructured client over here. And this is going to be running for as long as the server is going to be running. And we use that to create our fast MCP server in the last slide. And this would start your server for you. The sort of main thing about MCP is that you have an MCP and then server, and then the server has a bunch of tools under it that can now be accessed by any LLM, which is what we've done over here as well. We have taken what the unstructured API in its current form exists, and we've taken the different functions that we've implemented within that as tools within the MCP server. And the way to sort of implement a tool is really straightforward. You just have to wrap any sort of logic, Python logic that you have within an MCP tool decorator. And that's pretty much all you have to do. So I'm going to show you an example of what you're seeing on the screen right now, where list workflows is one of the functions that we have within the unstructured API, where given a particular unstructured account, you can list all of the workflows that exist in your account. So this, if you've used the unstructured platform UI before, you just click on the workflows tab and you can see all of your listed workflows, and we have the same capability through the API. Now we want to take this function and implement it within MCP. And for that, it's pretty simple, right? You look at the first line, you take the client that we kind of declared in the previous code that you saw, right? Through your lifespan, through your context, essentially, you're taking the client from the context. And then we're just using the standard unstructured API method list workflows request to generate our list of, request our list of workflows that exist within the account for this client. We do some sorting, we do all sorts of stuff. And then finally, we just return a string, right? And that's pretty much all this function does. We kind of wrap this thing entirely within a decorator called MCP tool. Over here, MCP is the server that you just created in the code in the previous slide. And now you're declaring that this is a tool that exists within that particular set of that particular server. So once you do that, there are lots of MCP compatible interfaces that you can use. Now you can use Claude Desktop, you can use Cursor, you can even like sort of run this locally. But a way to kind of quickly look at it is through Claude Desktop. And if you open that and you have the server running, which we will teach you how to do later on using the unstructured MCP server, you will see a small hammer icon on Claude looking like what you're seeing over there. And when you click on that, you'd see the list of all the tools that we support currently in the unstructured server. And when you go ahead and prompt something like, hey, what are the workflows in my unstructured platform? It's going to call the list workflows for MCP tool that we just wrote in the previous slide, and use that to list all of the workflows that you have in your account that you just authenticated using your environment variables. So some best practices for how to use this, when you're using like fast MCP, it's pretty straightforward. Since we have our built-in context management, it kind of helps really organize your code in a way that you kind of keep things like your environment variables in a certain place and whatnot. And if you want to come in and contribute and you want to kind of extend this is completely open source. So if you want to kind of extend the MCP server, a modular design is kind of the way to go. And we have kept our connectors in separate modules so that, let's say Pinecone as a connector tomorrow decides to completely refactor and deprecate all of their existing functions, it's quite easy for us to go in and update what the method usage is and all of that. Kind of keep things pretty simple to work with. Finally, don't forget to validate your inputs. MCP at the end of the day is still an LLM, and LLM will make mistakes. We've had so many mistakes that we saw the LLM make, even though we were asking it to use a function that is very simply written within our unstructured server. So at the end of the day, ensure that your inputs and outputs are validated so that nothing harmful goes through, no sensitive data gets leaked, and so on. But we have also kind of found really interesting ways to extend this our existing MCP server and see how it integrates across different ecosystems. And Ajay, I think, is going to take over now and tell you all how Unstructured kind of integrates with Firecrawl, which is another amazing framework you can use to extract and crawl information from the internet.
Thanks, Tarun. So yeah, what Tarun just explained was how you could just set up your own unstructured MCP server and how MCP in general works. So what I ended up doing was I took the unstructured MCP's document processing capabilities and I decided to extend it with this cool API that I saw around like the last couple of weeks. So Firecrawl, essentially you provide a URL to Firecrawl and you get back all the you get back like all the sites it crawled starting from that URL, either in a HTML format or in a markdown format. So say there's like a new technical documentation that just came out and that's like over like 70 URLs or something. And what you're probably looking for, is maybe the summary or maybe a key feature or maybe something about like how it does a feature A or something. So instead of you having to like go through all like 70 URLs or so, what if you could instead just use Firecrawl as a data source, crawl all the data, throw that into a data storage, and then use the unstructured MCP to take the data from Firecrawl data from the data storage, process it all the way, and throw that into like a destination vector store, and then just like run drag all over it. So yeah, that's pretty much what I ended up building, and we'll just go over that. So I integrated Firecrawl into the unstructured MCP. It's currently available and you could also clone it and play around. So all I ended up doing, like without this, I would have you would have had to like write your own Firecrawl related code, write like a good polling logic, and then like think about handling exceptions and so on. So so I ended up like doing all of that and I pushed that it's currently in the unstructured MCP repo right now. So in the end, when I start the server, the MCP server, and ask Claude, what happens is Claude pretty much knows what exactly like the all the functionalities that I've added and all the functionalities which unstructured MCP provides by default. So all we have to do beyond this is just go full plain text. No need for a single line of code, all plain text. So I just asked Claude to start a job for me to crawl like a particular URL. In this case, the model context protocol website itself. And yeah, it automatically started a Firecrawl job and it scraped the results out for me and threw that into like a S3 bucket. So now that like my data is all present somewhere, the next step is to start playing around with unstructured itself. So what I or like how I kind of broke down unstructured itself to make use of its document processing capabilities was just so I tried to split the entire thing into two things: A, connectors, and B, something called a workflow. So connectors are essentially the places where you store your data. A source connector is where your raw data is hosted, in this case, AWS S3. And our destination connector is where we have our LLM ready data. So AstraDB over here. Yeah. So I used Claude to just automatically create a source and destination connector using the unstructured MCP. It did it ASAP. I did not a single line of code involved, all text. And then I went straight into workflows. So workflows are just steps that unstructured takes to convert your raw data into something that can be used downstream. So over here, so you could either manually create your own workflow or you could use one of the predefined workflows that Unstructured provides. So I used one of the predefined workflows here, which is Platinum, or you could also use like create your own like workflow dictionary, which you just need to add like a couple of components and you're all good. So here, the MCP, the Claude automatically created a workflow for me, and it knew what I was asking for, so it automatically created a workflow, and then it also asked me by itself if it should to run it. Like it kind of understood that, like you first create a workflow and the next thing you do is also like but think about like I mentioned it to run it, but it also understood what I meant when I say run it. It didn't think about running the crawl job, it just thought about running the workflow, and it just started running the workflow. So the workflow all ran through, and the workflow we could also like track let the MCP like just check the workflow status and tell us if it's done. So the workflow is all done, and then I went right into the RAG part of things itself. So I just put together like a quick notebook where I connect to the AstraDB and then wrote a retriever to fetch similar documents for like any questions I ask. And it started giving me like good answers for like the entire documentation. So it crawled around like 23 URLs, and I didn't have to go through a single URL. Instead, like I just made Firecrawl do the job, Unstructured do the processing, and I just asked any questions that I wanted to know, and I got the answers for it. I'll just pass it on to Nina for the demos.
Great. So now that we've talked a bit about what we've built, now we'll just start all of the demos. So I'll start by demonstrating the unstructured UI, and that is you can use the MCP to set it up, or you can use the UI we've provided, and that will kind of drill into some of the features that we're enabling via MCP. And then Tarun will demonstrate the unstructured MCP usage with Claude. And then Ajay will demonstrate the full RAG pipeline with the integration of the unstructured MCP with Firecrawl. And so at the unstructured platform on the start page has a lot of different resources to help you get started. We have our documentation, blogs where we've blogged a lot about MCP recently. We have a Slack community linked there, and we share announcements about MCP there, as well as a spot to share some feedback. And the way that you would get started with using Unstructured via MCP, API, or UI is you would start by building a connector. I've got to log back in again. Okay, so to start a new connector, you would write the name and you would pick a source. Let's say you want to pull, Google files from Google Drive or files from Dropbox, Databricks, Confluence, Snowflake, wherever your data lives. You can set up multiple connectors to get all of your data into one workflow. And then you could also set up your destination connector. And for all of these connectors, like let's take a look at my S3 bucket here. To set those up, for example, you would use the bucket URI for S3. You would put in your AWS key and your AWS secret key. And there's a few other authentication methods as well. And all of this information, if you wanted to access via our API or MCP, you would just save these as environmental variables, and then they would get set up in exactly the same way that they're getting set up in the platform. And then for a workflow, you again could set these up via MCP as well, but then you'd also be able to access them in the UI if that was an easier way for you to make changes. So let's say I have the US Constitution in an S3 bucket, and I want to put it into Pinecone. I could just use the automatic strategy that we have that has all these various defaults. I'd want to make sure that my embedding model has the same dimensions as my destination connector. And then I want to make sure I'm not clicking reprocess all, because that way you can rerun jobs and get files that are updated or only new files to be processed, which saves a lot of money if you're trying to incrementally process your files. Once you've set up this default, you can go to your jobs and then, or actually go to those workflows and then run that workflow that you just set up. And then it'll show up in your jobs here. And you can also modify your workflow. So you can add more sources if you'd like, or add additional steps here, like a plugin. You can change the partitioner strategy. So I've set auto, which automatically sets the best partition strategy if it's text or complicated images where you'd want a VLM. You can set some enrichments like image enrichment, text enrichment, named entity recognition. You can edit the prompt that you're using. You can change your chunking options, turn on contextual chunking, swap out the embeddings to any of the ones we want. Maybe you want, code or law embeddings. And then you can also write to multiple destinations. I won't save this because I'm currently running it. And then you can just go to your jobs and you can see that this job finished, and it shows you all of the different steps that it went through, and that in your database here, you have your one structured file that's been written. And so these one file demos really don't do justice to how much we're scaling concurrency in terms of processing files. The time it takes to run one file is not the same scale that you're getting if you're running thousands or more files. So yeah, that's the unstructured UI in a nutshell. And now Tarun will talk about how you can use that same product via MCP.
Hey guys, let me quickly share my screen. So I'm guessing y'all can see my screen. So this is the unstructured official MCP server, the GitHub repo for it, and I'm just going to quickly show you what we can currently do and the different things that we how to kind of set this up, and also show you a quick demo using Claude Desktop and how to use it. So the MCP server, like I said, is essentially a server implementation with like a lot of tools within it. And the tools in our context are going to be all of the API functions that we currently support using the unstructured API. And what we're trying to do over here is the ability to use natural language to come in and say, hey, I want to do something within the platform, like any function that you just saw what Nina mentioned, and be able to have Claude kind of use the right tool to execute that for you. So if you look at how the MCP server currently works, we don't have a hosted version at the moment, but it's coming soon, so stay tuned. But you can kind of run this locally, and there are different ways that you can run it locally. You can just clone this and pull this up and say, hey, can you run server.py, and it's going to run. And you can access it through any MCP compatible interface, like I'd mentioned before, like Cursor or anything that you want. And the available tools that you have within these are, once again, like I mentioned, all of the different functionalities that we currently support for the unstructured platform UI or the API. And of course, like, if you're creating different connectors, like, you're using third-party, frameworks like S3 or like VV8 or any vector database or sorts, you got to also provide your environment variables for that so that we can kind of take care of how to use that internally and just do the job for you directly. And yeah, so the way, and we also have the Firecrawl integration. So the way you want to kind of configure these things differs based on your implementation. It's quite general in the sense that you can just simply clone this. And over here, we have a .env file template. Similar to what you're looking at over here, you can just like kind of add all of your own API keys, and the server is going to automatically pick them up and use them. This is the easiest way to do it. Another way, so if you're using Claude Desktop, there's a slight bit of configuration that you have to do. So if you're using Claude Desktop, you have to kind of mention that this is the directory with the server that exists, so that you don't have to kind of do the MCP run server.py. Every time you open Claude Desktop on your computer, it's going to automatically run all of the servers that exist that you have pointed to and have it ready for you to use, which is what we're going to demonstrate right now. So there's a little bit of configuration that's involved for that, where you just need to create a JSON file containing the MCP servers that you want to configure, that you want your Claude Desktop instance to look at. So for us, under MCP servers, we wanted to look at UNS MCP. We set up the command for what the Python interpreter that we're going to use. We standardize this usage by using UV, which is a really great package if you haven't tried it out. So we point it to our UV instance, and then we also provide the absolute path to the cloned repository that we have currently so that you can access the server.py instead and start the server automatically without you having to do anything for it. Here, this is another way to kind of establish your environment variables in case you have like a set of environment variables for one and another set of environment variables for another instance. You can just have a list of all of your environment variables specified in the MCP server, and this would override your .env template. So for example, for me, that would look like this. I have my JSON in this path in my home library, application support Claude and Claude Desktop config.json. This is my UV path that I need Claude to use to run my server because this contains all of my dependencies and everything inside. And this is the path to my cloned version of the unstructured MCP server. And within that, it's just going to take up server.py and run it for me. Once I've set this up, you can now go ahead and just open Claude Desktop, and it would run all the servers that have been pointed to in the config automatically. And you would see a small hammer icon like this, like we saw in that screenshot earlier. And this means that, hey, these are the MCP tools that are available based on the servers that you've mentioned. And when you click on it, you can see all of the different tools that we've implemented within the unstructured MCP server listed over here. So you see create S3 destination, create S3 source. You see stuff like deleting workflows, getting source connector info, getting workflow information, pretty much everything that you can currently do on the unstructured API today. And we're also adding a lot more connector support as we go. So right now we support VV8, S3, and a few others, but as we move ahead, we're going to be implementing a lot more. And you're going to be seeing like a whole bunch of them come out in the next couple of weeks. So the way you use it is just pretty straightforward, right? You just jump in and ask, hey, can you list all of my workflows? Simple as that. And we want Claude to understand our request, pick the right, oh no, that is not working. Let's try that again. I'm gonna cheat a little bit and say, hey, can you list all of my unstructured workflows? Yeah, so now I'm sorry about that. Sometimes LLMs are weird, but it knows that there are a lot of tools that it has access to. It picks the right tool that it needs to use. So we have list workflows, which is one of the tools that we had implemented. And it picks that up and asks if it can run that safely. And then I'm going to say, hey, you know what, go ahead and love. And it's going to run that function, use my unstructured API key, which I have configured in my .env file, and fetch all of my workflows in my unstructured platform. So it's like I said, it's basically just running a Python function in the backend, getting the results and showing it to you in a format that's readable and easily accessible. Now I don't have to go log in, do a whole bunch of things to be able to do this. Or like a more like kind of easier thing to do is let's kind of create like a S3 source connector, right? Like can you create a S3 source connector? I'm gonna pick this folder that I have. I'm going to copy the S3 URI, pointing to this folder. And this should basically call our create S3 source tool and create the thing for us because we have configured the unstructured API key in the backend. We also have our AWS keys configured in our .env file. So it should use all of that to automatically create the connector for us. Okay, that's great. So it's picked up on the create S3 source function that we wanted to use. And it has also written the kind of query params over here. I'm going to allow this to run with the thing that I've given. I could have also given a name. So great. It's gone ahead and run that function, and it's created this new connector for me. Now I can instantly verify this by just going to the platform, clicking on connectors. Yeah, so at 1/4/2025 at 10:35 a.m., I'm in PST, it has created a connector called Tarun Devrel MCP, and it has used my access key ID and my secret key that I have configured, and it also has the correct folder that I've mentioned over here. So yeah, this is like a quick peek into the kind of things that you can do through natural language. There are lots of different like use cases that this is extremely useful for. And you don't this we're kind of increasing the accessibility to come in and very easily use all of the things that we have to offer through the unstructured API. But that's it for my demo for today, and I'm gonna let Ajay take over and show you a cooler demo with Firecrawl.
Thanks, Tarun. Let me just share my screen. Okay. Yeah. So yeah, I'm just going to like walk through how we extended like Firecrawl to the unstructured MCP. So like yeah, so some of these steps took like a little bit of like a couple of minutes, maybe a minute or two. So I just pre-ran the demo, like the workflows right before the demo, so I can just walk you through everything that happened. So yeah, like since when I start Claude Desktop, what automatically happens is it connects to the unstructured MCP and it knows right now like what tools are being offered and so on. So if I'm not sure about like what arguments I should provide for anything or so on, I could just ask Claude what I need and it's going to like give me exactly like what I would need to like do something. So right now I wasn't sure, so I just asked Claude to give me like what I need for a crawl job, and it told me exactly what I needed. And then I just asked it to crawl like the website for me for a couple of URLs and asked it to store it here on S3, and it started doing that. It also like intuitively again knew that like it started a crawl job and that it has a function to check the status. So it could check the status and see like let me know like how much has been done and so on so on. So yeah, just a couple of tries where I was checking the status and then status was all done. So it told me that the data has been pushed and told me where exactly the data has been pushed. So one cool thing that I really enjoy about like this whole MCP hype right now is also that is the context that gets maintained. So I did not exactly provide like an S3 URI or anything here. I just told it, hey, just like use this S3 URI to create a source connector for me, and it automatically understood what I was referring to, and it created the connector for me. Like similarly, and then I asked it to create an AstroDB destination connector to use unstructured, and it also like did the same thing for me. I also noticed a bunch of cases where, like, if I just provided something like -20 instead of 20, uh, it would automatically just treat it as 20. Or sometimes, if I try forcing it to use a -20 or something, it might just say, "Hey, like, you're not allowed to provide this, so I'll just take this as a positive 20 or a positive 30 or something." All because of just like because it knows the code that is being written and it knows what exactly it needs to like run something. So it created the connectors for me. And then I asked it to start a workflow for me. So right now I provided a custom, like a default workflow. But you can also provide like your own custom workflow, and it created, so it tried to create a workflow, ran into an error, and then it automatically also fixed the error by itself. And then it created the workflow. Intuitively asked me about like running it, and then it started running the workflow as well. So some cool things that we also noticed over the team was this one time I think someone found out that Claude, so Claude tried creating a workflow. It couldn't quite figure it out exactly. So it instead like it instead like called the list workflows endpoint to like just show all the workflows, took the configurations from one of the previously created workflows and created a current workflow itself. So that was something that I found really cool because the LLM took a lot more extra steps than I asked it to and actually did the job for me. So I could use it to check status, and then once the status is all done, all the documents were all processed from the S3 source into like the AstroDB destination, all ready for like a downstream task. So while this whole process is going on, when you're implementing it yourself, you could also just log in straight into the unstructured platform itself and just check your job itself on the workflow. So I provided a Platinum workflow. For Platinum, we use a vision language model. Like we provide like a bunch of LLMs internally, and it automatically selected one of the LLMs and it went ahead with the workflow itself. Yeah, so I'll just jump straight into like the downstream task itself. So I just put together like a quick notebook, one to just connect to, get the, all you need is A, your Astra DB credentials on your Collab secrets, and then B, either your OpenAI API key or any other LLMs that you want to use, up to you. But we used OpenAI here for the generation aspect of the RAG part itself. So I just wrote like a couple of helper functions to connect to Astra DB to get like to convert my query into like an embedding for search. And I also wrote a retriever which would essentially take my embedding, convert my query, convert it to an embedding, find like the closest documents from Astra DB, and yeah, it was all like done. And I just started asking questions and it started giving me answers. So all of this while without like me having to like just go through the MCP website itself. Like all I did was run the unstructured MCP with Firecrawl. It did most of the work for me. So I could just ask questions about what I wanted, and I know it was reliable enough to like get the answers where I wanted. So yeah, I asked about what MCP was. It gave me an explanation. It also gave me this cool flowchart, which I found on the website here. So yeah, I think so what probably happened on the back end was Unstructured saw this, thought this could be relevant, like understood that this is relevant context, and also had this embedded. So this could be used as context itself for answering questions. Yeah, it gave me an intro, and then yeah, just gave me a quick, I asked it how I could get started, gave me a quick summary on that. And then yeah, I think Tarun also mentioned using fast MCP. So I asked it to give me like a quick example. It gave me a quick example. And then also, yeah, I could also just use it for like debugging things itself, like whatever I was facing when I tried to set up Claude Desktop in the first place. So yeah, that's kind of around like how I integrated Firecrawl into like Unstructured and played around with it. Yeah, now back to Nina.
Thanks, Ajay and Tarun, for your awesome demos. It's so impressive what you've been able to build just over the last few weeks. Speaking of building around our unstructured MCP, we hosted a hackathon and we wanted to share some of the winners from that. So we hosted a virtual hackathon last week. The challenge was for folks to build an MCP server using unstructured API that solves their use case and to create a tutorial. And the prizes were $500 for the 3 winners at the end of the virtual hackathon. So one of the winners was James Kenyeri, who combined M-Pace's Daraja API with Unstructured API to build a financial workflow automation system to enable AI-powered invoice processing and payment automation. So what you could see is that you can ask for the process invoice details after going through all the setup and putting in your invoices, and then it can help you make a payment via M-Pesa. And you can just pay your invoices via an LLM. Super cool. Another winner also used invoice data, Nancy Amandi. Her project was to help business users analyze their invoice data by talking to Claude, and that was powered by Unstructured MCP. The data was stored in MongoDB and could enable natural language queries about vendors, payment dates, and service costs. So, for example, you could ask how many purchases and how much money have I spent on vendor bills so far? And then it would go through all of those bills that you had in your Google Drive via the full end-to-end pipeline with MongoDB as the destination. And then it would give you your analysis, it would give you all of your different results. It would pull up information from each one and give you a summary. Super cool. And our third winner was Heat Vicaria. That project was to develop an MCP server to extract structured data from research papers using Unstructured's API, which would enable researchers to efficiently organize and analyze academic literature for better literature reviews. So those research paper PDFs would connect to a source connector, which would then be processed and loaded to a destination connector, and then the user could ping the MCP client through this and leverage this server as a tool. So yeah, these are the winners from those projects. So if you want to get more information, you can go to our enterprise page and sign up to get a no-cost guided proof of concept with our enterprise team. You could get started with Unstructured today with a 14-day free trial on our developer page. And then I've linked here also the GitHub to run your Unstructured MCP locally. And we will now jump to the Q&A and answer some questions. So there's a question from Suvasis. What transport does Unstructured MCP use? Tarun or Ajay, do you know the answer to
I
that?
can take that. Yeah, unstructured MCP uses the standard input-output transport.
Great, thanks. Question from Banu. How can Unstructured help smart home real estate home builder startup founder using Autodesk? So if you have a specific use case for using Unstructured, I encourage you to go to our enterprise site and connect there, and our sales team can kind of walk you through different things you can do with Unstructured via MCP or otherwise. Oh, I'm seeing sometimes my screen share gets, okay, a little messed up. So yeah, so then we'll go to some questions from that were pre-submitted before the session. So one of the questions was, which is the best language for this kind of work? Python, JavaScript, Go, or Rust? Tarun, can you answer this question?
Yeah, sure. So we've implemented the unstructured MCP server itself in Python, in pure Python. And that's what's going to be running on. But like I said, it's a server API at the end of the day, and how you query it is kind of left to you. MCP by itself supports JavaScript and everything. So any sort of client-side language should work.
Thanks. There's a follow-up question from Suvasis. Can transport layer be changed for unstructured MCP?
Ajay, you want to take that?
Yeah, sure. So we are building another like hosted version which should have a different transport layer itself.
Cool, thanks. And let's see. Then there's another question I see in the chat. I encourage folks to put the questions in the Q&A instead, but I happened to catch this one. Question from James. Is there an option to specify my own embedding model, maybe my passing API?
Yeah.
Oh, maybe by passing your API key. I can answer on the unstructured UI side. So there, we have the embedding options that we have, but you could also skip the embedding step and set up your own embedding. Let's say you run your workflow to do chunking and maybe write it to blob storage, and then you can run your own embeddings. For example, Tarun or Jay, I don't know if you know another way to do this via MCP specifically.
No, I think right now the MCP server is a derivative of the unstructured API, and we do support a lot of different embedding models, like Nina mentioned. Like we have together AI embeddings and whatnot, and we're going to be adding support for a lot more soon. You can use anything that's within that at the moment.
Great, thanks. There's a question from Roberto. I work at a scientific center. Can I get more information about the third hackathon project to understand better how Unstructured can help us here with MCP and AI? Yes, so in the slide deck that we'll share, there's a link to a blog post and a GitHub. And so when you receive the video and slide deck, you can just go find all of the references to everything that we talked about as links on each of the slides. And then question for Matt in the chat. Separate question, can Claude via MCP help compare retrieval using different chunking strategies or embedding dimension, basically using the LLM to identify this answer was more responsive to the question using X embedding / chunking strategy?
I can take that.
Mhm.
Yeah, that's actually a really nice idea, to be very honest, because the kind of novelty that MCP brings is the ability to kind of programmatically, or like, even through like natural language, start and access different workflows within the unstructured platform. So if you want to create different, for a particular source location with your files, if you want to create different, like, have the LLM create different workflows with different chunking, different embedding models, and kind of run them concurrently, this does make it quite simple for you to do that. Because the MCP layer takes care of all of your tool calls to kind of create different workflows iteratively. It understands what you're looking for when you're trying to create different workflows and kind of gives you an exhaustive version of it. Yeah, that should be possible.
Yeah, that's a great question. Question from Haha. How does MCP handle data security and access control when exposing unstructured data to LLMs like Claude? So on the unstructured API side, we encrypt your data during processing, and we don't store any of your data, and we basically delete it as soon as the job is done. So, so that's how we're handling things on the unstructured side. And then we also provide role-based access control that you can leverage in your downstream application like LLMs and Claude. So we can also help track the security metadata, for example, know who can access that file that was originally shared. And this is all on the unstructured side. So you would need to basically build out the next steps that leverage that data that we're providing in the metadata to ensure access control and data security on your application. Tarun or Jay, I don't know if you have anything else to add specific to Claude or MCP.
Yeah, I guess, like I said, sorry, I keep saying this, but MCP just accesses the unstructured API. The unstructured API is an enterprise-grade API with all of your access control and all sorts of security compliance like kind of baked into it. So through MCP, you're not essentially like doing anything that's specific, that's outside from a security context from the unstructured API.
Great, thanks. Let's see, we have a pre-submitted question from Francis. How does MCP compare with Crew AI? Tarun, I know you've used Crew AI in other projects.
Yeah, I can take this one. So Crew AI is an agent orchestration framework that allows you to have LLMs talk to each other in several orchestration use tools like the ones you've seen in MCP to kind of perform operations. That's what it is. It's kind of like a complete framework for you to work with agents and kind of abstract that out for you. MCP is literally just a standardization layer where you're saying, how does an LLM know how to say access my emails? So like how does it know how to do it? So if a better comparison would be to compare tools within Crew AI, tool support within Crew AI with MCP, because they're both pretty much the same, right? But the difference comes from the fact that MCP follows a client server architecture, whereas tools are just like, an agent locally or like in some hosted area running Python code that it has access to. So that's kind of the difference. You can say that MCP is basically kind of a standardized way to write your tools. Agent frameworks did not kind of come in and do that. They just said, hey, if you have like a Python function, you can kind of attach that to your agent workflow this way. but LLMs don't have that sense of standardized information of how to kind of access which tool and when to use what tool. And we're bringing that standardization into the picture using MCP.
Great, thanks. Another question in the chat, what are some common pitfalls or anti-patterns seen in early MCP server implementations?
I can take that. So yeah, like one very common pitfall that we noticed was like things start being decoupled. So yeah, like there's a lot of times when like you might add new features or when like documentations change in the future, like when versions get updated or something. Like Tarun mentioned, you might have to change a couple of things on the API end itself. So making sure things are as decoupled as possible helps in terms of like the implementations.
Great, thanks. Tarun, is there anything you want to add to that?
Yeah, like I said, like Ajay said, being modular is the way to go because you can kind of trace back to why something isn't working the way it does. We did have like I think the most of the problem came from the fact that we kind of had to follow a certain. Okay, let me put it this way: just write better code when you're writing your Python tools, because the LLM when it runs, like let's say there are certain arguments as part of your function that are not clearly defined or like it doesn't have clear documentation for, the LLM is going to get a little confused in terms of how to use it. So I think the single most common issue that we ran into was making the server or the function call use the right environment variables, know that it's there and everything. So it just took us some time to figure it out because we didn't really we didn't use Ajay's Firecrawl implementation to ask the correct questions, and we didn't end up reading all of the documentation. So but no, that's pretty much it. Just keep things modular so that you can kind of trace back to where your errors are coming from, because it's not going to be reliable in the sense that there are certain times, like you saw in my demo, that you ask something and it's not executed. So ensure that you're validating your inputs and the outputs from the LLM to ensure that something, whatever operation that you're executing through your tool is actually happening.
Yeah, another comment in the chat, perhaps a blog from your MCP implementation might help the community. So yes, we actually, on our blog site, we have blogs about our hackathon. We have a new blog on building an end-to-end pipeline with custom NER using MCP. We have one on Firecrawl work that we presented earlier, as well as on building an MCP server. So we have, we do blog very, very frequently to help the community. And then one last question that was pre-submitted. If the tool does what it claims it could do, this could be the beginning of the end for complex spreadsheet setups. I have 3 questions. One, will this be a tool that is affordable on a department basis or requires a large-scale buy-in from companies as a whole? So if it's a larger company or department, you may want to contact our enterprise team. You can get discounts from them for prepaying for your processing, but otherwise this is intended for individual developers. Pricing is per page, and you can just sign up on the developers page and get started. Today, you don't need you don't need to have an enterprise level usage or use case to use it. 2, is the company the sole owner of the data, or will the platform use company data for learning, creating a security concern? So as I mentioned, our SaaS product does not retain any of the data, and we encrypt it. So we're absolutely not using it for any of our own learnings. We've provided a free API before that that would let us where the terms were that we could leverage that data for our own learning. So that was one way that we were able to leverage data with buy-in, but then all of these SaaS products are no access from Unstructured. And then what talent level will be needed to operate Unstructured? So the UI you can use without any code. The API you would need developer skill set, but then the MCP setup that we demonstrated today, that can be done, I would say, with some developer knowledge, but a lot of what you're doing can be done with natural language. So I think we aim to get the skill level needed to be as minimal as possible, so this can be accessible by everyone. Thanks everyone for joining today. Thanks for a lively discussion. Thanks Tarun and Ajay for demonstrating the work that you've built recently. And thanks everyone for taking an hour out of your day to join us and learn about MCP. We'll have a follow-on session on this in the next month or so to talk about our deployment of a MCP server. And we have another webinar in a couple of weeks about building knowledge graphs with Astra. So check our webinar page to see what we have coming up. Thanks, everyone. Bye.
Thank you so much for joining. Bye.
Right.